gold in the lab, Twitch stream glowing, formulas flashing, minds wide, knowledge flowing, equations on the board, numbers never sleep, teaching math and physics while them haters count sheep. Actual education, tune in and get schooled, flipping textbooks, breaking all the rules, from Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex, quantum theories on deck, breaking all the specs, relativity theories, worlds getting small, grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep, grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold, brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice.
All right, what's going on?
Bing bang.
Welcome, welcome, welcome. Happy Friday. Let's start this off. Oh, there's an event. Why did I not know that the event's happening today? One sec. Need this to fix. Yeah. Oh, what? No. The Gilded Method should be today. Why did I say it was next Friday? Let me edit this event. It's today, not the 30th. There we go. Okay, maybe that fixed it. Oh, whatever. Okay. What's up, Taylor Reed? Good to see you. Yeah, so here we go. The Gilded. Just waiting for the Gilded Method featuring Naroski. There we go. Nice. I don't know why I just called it Naroski stream. I should call it the Gilded Method. Dun, dun, dun. Why, hello. What's up? What's up, Alistair? What's up, Michael? All right, the Gilded Method featuring Naroski. Where is our Romanian vampire? Where is he?
Oh, yeah. Good job.
What's up, Taco Cat? Good to see you. Also, let me fix this. 15 frames per second? That's fucking garbage. 30 at least. There we go. That's better. Much better. Okay, what's up, Taco? What's up, Alistair? Let's see. Today is Friday. We're going to be doing a very special stream today where we're going to go over kind of more like competition style math and some like fun, elegant solutions and stuff. So usually our streams during the week are just to help you guys out with math and science homework, which is cool. I like it, right? Who's the beefcake streaming? I have become an absolute beefcake, Michael. Although I am on my cutting phase now. I'm beginning to drop some weight. I hit my maximum of, was it 206? Yeah. That's more than Korea. I think Korea was at like 190. Which, has anyone seen, like, apparently there's this huge trend going on about like hashtag 2016 or something. People are trying to be like nostalgic about 2016. I was like, 2016 I don't think it was like that crazy, right? But then I looked back through my photo album and like, yeah, 2016 was fucking wild. Yeah, it was actually the first time, and probably actually the only time I've been to Korea was 2016. I was posting it on my Instagram. Maybe I'll show it to you guys. If you want to see Dr. G like before the Gilded era. It was 2016, Michael. It was end of 2016, actually. Yeah, right? It's crazy. Crazy. Yeah, that's the Suki era. But yeah, this was me in 2016 when I had bleach white hair. Yeah, Dan got married 2017, I guess. Yeah, because then that was the golden era. Yeah, that was the golden age. Yeah. So 2016, this was this was me and all my sisters too. I posted it as well, just to kind of see all of us. But yeah, it was a very interesting period of my life. I kind of call it probably one of the darkest years of my life because I don't know, I was going through like a lot of stuff that year. Anyways. Yeah, it was fun. So I see a lot of people posting about it, about 2016. We're still here, exactly. But that was a decade ago. 10 years, man. Although I was a completely different person 10 years ago. I think most of the people here probably on the stream, like 10 years ago, you guys were still in elementary school or something, right? I think what's happening is like Gen Z is now getting nostalgic for how good things were. I guess like probably like pre-COVID, and they're like, oh, 10 years ago. To me, it's not like that crazy. I'm just like, okay, I was still in grad school. I was traveling the world a lot, but nothing like super insane. All right, let's see. I'm pretty sure I told Naroski it would be this Friday. Yeah, he knows it's this Friday. Although, to be honest, like, Naroski is in Romania. So let's see what time it is in time in Romania. He might be sleeping. 2:07 a.m. No, he should be waking up.
Yeah.
Here, we're gonna ping him till he wakes up. What's up, Shag? Good to see you. We are gonna play Rocket League later this afternoon. So I told you guys that this year, one of my big things I wanted to recommit is to doing more video games with you guys. So yes, at 6 p.m., so in about 2 hours.
Hell yeah.
We're gonna do some Rocket League, right, Shaq? Yeah.
Yeah, you ready to lose?
You ready to lose, dude?
How many entries am I getting? Am I getting 2, 3, maybe 4 entries?
Oh man. Yeah, I said any student. You're gonna go play Fortnite. Ping me if I'm not. Yeah, no, for sure. Yeah, we're not doing any homework questions today. I know people might think we're doing homework questions. We're not doing homework questions today. This is gonna be strictly a cool, fun competition math stream. Is what we're gonna be doing. I'm gonna give Naroski like 5 more minutes to wake up. Otherwise, I will just start doing competition math stuff myself, and I'll try to struggle with you guys and show you what I do for competition math. Let's see. I wanted to. So yeah, you guys voted on Game of the Week for today, for Friday, and you guys came up with Rocket League. So we're gonna play that at 6 o'clock. Come on by the. We'll do it in the Recess channel, and then also it'll be on our sister station on Twitch, which is Actual Gaming. I want to like keep the education and the gaming stuff on like separate streams. So Actual Gaming here, we'll have all the video game stuff we did. Streaming. So what was it? Last week we did. We still got all these ads. I don't get paid from these ads. Last week we did Fall Guys. This was really fun.
Good job.
Had a lot of fun with Shaq and stuff. We were all playing Fall Guys. This game I remember coming out really around like COVID, but it's still alive and there's still a ton of people in it, and it's super fun. So that was kind of a goal for me this year, is to remember that we're not just doing math and science homework all the time. You know, we can still like have fun. I mean, that's the whole reason we created Discord. Otherwise, like this should be lame. This shit would just be lame and cringe. Yeah. Okay. Let me post that. Let me clear all that. Let me go check the calendar real quick to make sure I'm not crazy. I'm very sure I set this time on the calendar. Yeah, right? Didn't I? Yes. Yeah, this is Naroski. Okay, cool. All right. Let's see. I'm going to go check out... So Shantrix, I think, always gets things from... What is it? The Waterloo Math Competition? Math contest or something, right? Yeah, there we go. It's these ones. These are the ones that used to always give me so much struggle. Or not happy. No. These used to give me so much struggle earlier when I was streaming. And now I've gotten, like, decent at them. Because... it's just from experience. Yeah, it's the Pascal, the Cayley, and the Fermat are the big ones. Oh, there's a Euclid contest too? Okay, so Euclid is grade 12. I don't think we want to try this. That might be a little difficult. Because competition math at grade 12 is, yeah, a little insane. But 9th through 11th, I think, is okay. Yeah, and then let's see. Critical thinking. There's some other really cool ones. The Gauss contests. Oh, and this is grades 7 to 8. Oh, fun. Yeah, I did a lot of math competitions when I was in, what was it, middle school at Mitchell? No, Branch Crossing is what it was, right? Yeah, we had Mu Alpha Theta. It was my first introduction to, like, Greek life, I guess, right? But yeah, I used to be part of the math club there. Okay, let's see. So I don't think we want the Beaver. The Beaver seems easy. I think we want, like, the Cayley. Where's the Cayley? Let's do, like, grade 10, I think. Canadian math team. Where are the Cayley tests? Oh, there we go. Here we go. Cayley. Yeah, okay, cool. All right. Let's see from last year, actually. Yeah, well, here we go. And then here, we can download the contests. And then we're going to download the solutions as well. Because I need to be able to see whether I'm doing something correct or not. Okay. Dude, Adobe Acrobat needs to chill out, dude. Here we go. Alright. Cayley contests. That's what this one is. Okay. So, competition math is usually... it's not your average, just learning pre-calc or whatever you learned in, like, algebra in your classroom. These are designed to be tricky, and they're designed to, like, kind of mess with you. And so, what you have to do when you see these types of questions is the immediate obvious answer is usually the wrong answer. And then I want to see... Okay, so part of it is actually... there are numbers, and part of it... Oh, they do have multiple choice. Oh, okay, cool. I like these. Have you done any time series analysis beyond the basic... besides Fourier analysis? Not really. Or are you talking about maybe Laplace transforms? I've done those as well. This is like a pretty... You know what's so funny about this contest is that the first couple questions are always, like, really, really easy, but it's the last two or something that just are an absolute nightmare. Okay, so let's see. I think I want to try, like, one of... Yeah, let's do this one. Let's do this one. I kind of like this one. Question 21. Doesn't look too crazy yet. Okay, cool. Says points -3, 5, 0, 7, and C, which is R, T, lie along a line. If BC is equal to 4 times AB and R is greater than 0, what is the value of R plus T? Wow. Okay. So, one key thing, whenever you see these types of questions, you want to look at the wording and try to identify why they're giving you information. Almost always, every little bit of information they give you on one of these word problems is used for the question. It's not like your high school or middle school tests where teachers put extra information or, like, red herring shit that's, like, not useful. They usually, everything means something to the question. So in this case, like, they lie along a line. Well, what does it mean when points all lie along a line? it means that the slopes of, let's say, for instance, AB as a segment and BC are the same. Right? So, and also the slope, so let's see, like let's say this is like point A, this is point B, this is point C. If they all, or let's make them diagonal actually, so you guys can see it a little bit. And AC, exactly, Jeff, right? Yeah, exactly. Okay, so if we have point A, point B, and point C, exactly. So AB has to have the same slope as BC. And also, yeah, the key thing here is that they also have to have the same slope as A to C. Otherwise, you could have something like this, for instance. I'm trying to think. Wait, could you have a case, Jeff, where A and B have the same slope, B and C have the same slope, but A and C do not? I don't know if you could. Yeah, right? I'm trying to think. Like, I was thinking at first, wait, you could just have like two parallel lines, right? But then, yeah, these would be two different points. Okay, so this is true. So A to B and B to C and also A to C are the same. I think this is sufficient information here. Okay. So from that, you can then write equations involving the points they gave us, and we got to think about like what are the equations that we already know that deal with these. And so one thing we know is we know the equation of a slope, right? A slope is always like y2 minus y1 over x2 minus x1. Okay? So let's figure out what the slope of AB is. That might just help us out, right? So the slope of AB, we're going to call this, let's call this like 0.1, let's call this like 0.2. So y2 minus y1, that's going to be 7 minus 5 over x2 minus x1. So that's going to be 0 minus negative 3. So that's going to give us 2 over 3. Okay, great. That's a nice number to know. The slope is 2/3. Now we can use that to maybe get some more information about R and T, which are variables that describe point C. Because I know also that the slope of BC has to be equal to 2/3. And let's figure out, like, equation-wise, what the slope of BC is. So the slope of BC would be this y point minus this y point. So that's going to be t minus 7 over r minus 0. And this also has to equal 2/3 because the slopes have to be the same. Now, cool. So this is one equation with two unknowns, right? So I don't know t, I don't know r. Those are two unknowns. And I have one equation. In general, the big trick in algebra, whenever you're trying to solve for missing variables, is you need at least the number of equations as you have missing things. So if I have two things missing, I need two equations. And those equations need to be what are called technically linear independent, which is a big fancy math word for they just can't, the equations can't be like combinations of each other. They can't be copies. They can't be just like multiples. They have to be distinct, like different. So let's maybe look at what the slope of AC is. I wonder if that's going to be an independent equation. Let's do it. So AC would be looking at between here and here. Okay. So that's going to be t minus 5. All over r minus 3. Okay. So that's going to be, what is it? And that's also equal to 2/3. Okay, cool. So maybe we have some information here that'll already help us out. Let's see. Curious. Okay, so from this, you get that like t minus 7 is equal to 2r over 3, right? If we take this and multiply up on the top. And then from this one, you get t minus 5 is equal to, this is going to be r plus 3 over 3, right? Because r minus 3 is r plus 3, so you get 2/3 r plus 3. Now, let's see if this gives us anything new. I'm curious. I think maybe it does actually already. Okay, because I could distribute this in, right? And so that would get me that t minus 5 is equal to 2/3 r plus 2. Oh, and that's, here's the funny thing. Here's the funny thing, guys, right? This is why, and Jeff, this is also why I don't think this is new information. I think assuming that AB and BC have the same slope automatically means that AC. You don't need, the AC information doesn't provide you anything new. And we can see why that is. Because this equation right here, if I were to subtract 2 on both sides, note that I would get t minus 7 is equal to 2/3 r. And that's the exact same as this, right? So, unfortunately, that doesn't help us out. And this is an example of what I say that the equations have to be linearly independent, because this equation is basically the same shit as this equation. Even if we were to, for instance, like multiply everything by 3, it would still be not linearly independent. It would be linearly dependent is what they call it. Okay. So technically factual, but not helpful. Yeah. Reminds me of a lot of things in life, right? Technically factual, but not helpful. No. Okay, so this is useful. We know this. Okay. I think the next bit of information that we want to use here, however, is this, right? We say that the length of BC is equal to 4 times the length of AB. All right? So there's actually kind of a couple ways to do this, right? Because if BC is equal to 4AB, so let's right, so BC, so we say this is equal to 4, and let's say, like, for instance, this is equal to 1. Then, or here, what we should say, let's call this A, and let's call this, like, 4A. Then the length of AC is equal to 5A. Right? Because A plus 4 times A would get you 5A. Because this is 4 times whatever this distance is. And we assume they're all connected to each other. Okay. But I think, just to start off with, we can come up for what the distance of BC would be. And this goes back to the distance equation. So the distance equation would say that BC is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Which for BC, that's going to be the square root of r minus 0. So r minus 0 squared plus t minus 7 squared. Okay. Which, I don't know if that's actually really nice, right? That's the square root of r squared plus t minus 7 squared. Kind of yuck. Okay, but it might be what we have to do. And that's equal to 4 times the length of AB. So let's get the length of AB. The nice thing is that AB are numbers. So this should be a nice little number. So AB is going to be 7 minus 5 squared plus 0 minus 3 squared. Which, that's going to get you the square root of 7 minus 5 is 2. 2 squared is 4. And then 3 squared is 9. So that's going to equal the square root of 13. Oh, okay. Interesting. Okay. So this was BC. This right here was AB. And we know this is equal to 4 times this. Not a very nice thing, actually, right? Okay. But actually, ooh, the squaring will make things nice. Watch. Okay. So I get that the square root of r squared plus t minus 7 squared is equal to 4 times the square root of 13. Okay, cool. I think we want to get something just in terms of r and t. So we really don't like these square roots. Like these mess things up. Luckily, there's nothing crazy over here. This isn't like plus x or like, like minus 2 or something. So what we can do is we can square both sides. And then, yeah, Jeff has the exact thing we're going to do next. Okay. So we're going to square both sides. Square both sides. Because that's going to get rid of the square root. And so now we'll have r squared plus t minus 7 squared is equal to this squared. So 4 squared is going to be 16. Square root of 13 squared is just going to be 13. Okay. And then what is 16 times 13? I forget if you get a calculator on these tests. You probably don't. You probably just need to know this, but okay. So this is equal to 208. If I really wanted to do that, I would say that 10 times 16 is 160. And then 3 times 16 is 48. And 48 plus 160 gets you 208. That's the way to do it in your head. Okay, this is r squared plus t minus 7 squared. And then Jeff had something really cool. Yep. Jeff said, wait a minute. So from before, when we did the slopes are equal, we know what t minus 7 is. T minus 7 is 2r over 3. So I can plug that in over here. Okay. So that's going to be r squared. Well, here, let me write it down a little bit. R squared plus 2r over 3 squared is equal to 208. Okay. So when we multiply this through, we're going to get r squared plus 4r squared over 9 is equal to 208. And so that's going to be 13 over 9 r squared is equal to 208. Is this going to be nice? Man. And then... man, because wait. I don't think 208... Oh, 208 is 16 divided... Oh, yeah, duh. Oh, no. See. Yep, okay. Great. Thank you. I was like, wait, does 13 go into 208? Yeah, duh, it already did. That's how I got it. Okay. So divide both sides by 13. Alright. And then we can multiply both sides by 9, right? So this will get you that r squared is equal to 9 times 16. Okay? Exactly. Right, and this is beautiful, right? Because if I square root both sides now... Okay. Here's a cool thing. So, I could, like, multiply this through, right? And that would get me 144. You can also recognize that this is the same thing as the square root of 3 squared times the square root of 4 squared, which I think is what Jeff is doing. And then square root of 3 squared is just 3, square root of 4 squared is just 4. And so you get r is equal to 3 times 4, which is equal to 12. Cool, so r is 12. Great. But I think what they wanted... So they want the value of r plus t. Okay, so if r equals 12, you can then substitute in here to see what you get. So you get that, like, t minus 7 is equal to 2/3 times 12. So, what's that? 2/3 is 8. So t equals 15. So then r plus t is equal to 27. Final answer 27? Let's go check it. Let's go see if that's what it was. I do have the solutions here. And what one? That was Kaylee question 21. Wow, look at this. Look at this solution for this, by the way. Look at all this. Wow. I think this is kind of like the same amount of work we did. But yes, they got the final answer is 27. Now, I mean, the cool thing about these types of competition questions is you can actually go look at what the solutions would have been. So, and how they solved it. So, they plotted the points. -3, 5, 0, 7. And then they knew that C was up here at R, T. And they used similar triangles. Oh, fascinating. Right, okay. That's cool. This is a little... I mean, this is... Again, this is probably the more elegant way to do it. So when we talk about like elegant math, I think this is a more elegant way to solve it, is to draw it out and recognize that these are geometrical relationships that can make things simpler. But then they had to use the distance formula anyways. Oh, wait. Oh, sorry. This is the whole solution. That's just this. Oh, wow. This is just, they got right here to R equal, they just got to 27. Oh, that's super cool. I did this, right? Distance formula was that, and then that the slopes have to be the same. We use solution 2. Solution 2, I think, took a lot more time, though. Solution 1 maybe took a little bit more time to set up, but the math behind it are is a lot simpler, I think. Oh, that's cool. Wait, how did they know this was 0,5? Plot points A, B, and C as well as D. Sorry, what? So I hate when they do this in math competitions where they just start. These are called auxiliary lines or like auxiliary points. And doing these is not so obvious, I guess. You have to have a certain type of intuitive math brain to think, oh, I'm just going to create some auxiliary points here. Yeah, I guess they saw, okay, so that ABD, let me see this, ABD and BCE are right triangles with angles at D and E respectively. Have a horizontal side and a vertical side. Yes, since AB and C are all on the same line, AD is parallel to BE, sure, and BD is parallel to CE. And so then they make the argument that DAB, that angle, has to be equal to angle EBC, and then that DBA is equal to ECB. This is a cool geometry argument. Hence, they're similar triangles. Oh, and now you just have a ratio of sides. Oh, wow. And then, right, it's given that BC is equal to 4AB, so then you can use that, I think, to figure out what the length of CE is compared to the length of DB, and then DB is known. Okay, very cool. Then you get R equals 12. This is cool. This geometry argument is really fun. I understand this. If anyone in the chat does not, I'm happy to go through this one. Just the geometry argument. There's a lot of, this is where it helps to know when you can make assumptions like this is parallel, these things are similar, and thus then you can use common ratios to solve. If you don't mind, yeah, let me do it. Yeah, here, let me go through this solution. Actually, let me try to do it without looking at it. Let's do that maybe, yeah? Yeah, let me try to do this. Let me do because it's one thing to I always say there's a difference between passive learning and active learning, right? So passive learning is when you just like listen to a presentation, read a PowerPoint, or I don't know, see your notes. Active learning is when you like actually have to actively do something, and that to me is a much better transfer of knowledge to your brain. If you are just passively learning, just listening to class, or like just I'm gonna go through the lecture slides, you're not really learning. Your brain's just like kind of on autopilot. It's probably thinking about other things while you're doing this. But if you force yourself to do something actively, this can even be like copying down notes, like just writing things, you will do much better in retaining the knowledge. So I could just read through the solution and show it to you, but I think it's a lot more impactful if I try to solve it myself. So let's see. So this is our coordinate axis, right? And we have these points, which we know, right? We know A is at -3, 5. Okay, so that's like -3 over, and it's 5 up, okay? So this is point A. And then point B is at 0. Ooh. Wait, where'd my whole thing go? Sorry. There you go. Sorry. Point B is at 0, 7. Okay, so that's 0, we'll just say 7. Let's say this is point B. Or like, let's do something like this. Like, make that point B. So this is... And then maybe it would help to kind of draw out like what the distances are, right? So this, we know, is going to be located 5 up. And this right here is 3, right? And then this, because it's 7 up, right? This is going to be located up another 2. Right? 5 plus 2 will get me the 0, 7. And then we know that there's some mystery point out here. Some point C. That is at R, comma, T. And these are all along the same line, right? We know these all share the same line. Okay, if I know they all share the same line, right? I could try to make another triangle. Let's say right out here, okay? Where I know that the distance from here to here, that has to be R, right? This would have to be R. And then the distance from here to here, okay, is not T. Because T is the Y coordinate. And that Y coordinate is the total distance from here up to here. So if this right here is if this whole distance here is T, and then this distance right here is 7, right? Because 2 plus 5 in the up direction is 7. That means that this component here is T minus 7. Okay. Now we need to think about the triangles. Okay. So, I know by definition, right, that this is a right angle and then this is a right angle. Because literally, right, we're going like horizontally across and we're going vertically up. Horizontally. I know this is not probably the correct mathematical term, but I think it's pretty obvious for us to see that these must make right angles. Now, if these make right angles and these are parallel lines because they're both horizontal, that tells me by a property of what are called transversals, right? So if I have two parallel lines and if I have a big transversal going through it, transversal is like a line that traverses across these two parallel lines, I know that this angle must equal this angle. And that's by what's called corresponding angles, is technically the theorem. This solution leans very heavily on geometry knowledge. I know a lot of people skip geometry. I call geometry like the ugly stepsister of math. But it does have some really cool properties that you can use in other areas of math. And this is a case of one of them. So this angle is equal to this angle by one of the transversal properties, okay? And then similarly, right? Sup, nerds? What's up, Psychode? Okay. These are triangles, right? So they both add up to 180. So I know whatever this angle is has to be equal to the same angle as this. The reason for that, right, is that this plus this have to be 180. And this plus this have to also be 180 to make triangles. But the bottom angles on both triangles are the same. Right? The sum of them is the same, right? It's a 90 plus something green, a 90 plus something green. So this angle must also equal this angle. You can also kind of see it this way. You can say that like, oh, if this is A, B, C, and then let's call this like D, E, F. I know that A plus B plus C has to equal D plus E plus F. But A plus B equals D plus E, right? This equals this. And so that tells me that C equals F. That's like the formal geometry proof for it. Does that make sense so far, Material Read? how we've set that up? Let me know if not. Cool. Okay. Now this is a very cool thing in geometry. If you have two triangles and all of their angles are the same, like they have similar angles between the two of them, then they're called similar triangles, and then the ratio of their sides are also equal. So for instance, the ratio, and let's draw our two triangles. Let's do two different colors here. So we have this, right? We have blue triangle, or a purple triangle, right? Call it whatever. Kind of looks purplish. Purple triangle versus, let's say, like, orange triangle. We can then say that the ratio of the hypotenuses, the hypotenae of the two triangles, so AB over BC, that ratio must equal the same ratio as, let's say, for instance, this side to this side. It's probably blue. Yeah, someone's probably colorblind. All right, so this side to this side, hypotenuse to hypotenuse, is the same ratio as this side to this side, right? 3 over r. And what we were told here, right, is that, oh, well, BC is 4 times AB. So I already know what this ratio is, right? If BC is 4 times AB, then this is 1 over 4 is equal to 3 over r, right? BC to AB, right? You could also see it this way if you wanted to. If we wanted to, like, divide this over, you get BC over AB is equal to 4. So AB over BC is equal to 1 over 4. And now from here, this is just simple cross multiplying. You just get the r equals 12. Okay, and then once you know r equals 12, right? Now you can do the ratio of the hypotenuses to the ratio of the vertical sides. So I can say, okay, well, AB over BC, which we know is equal to 1 over 4, is the same thing as this one to this one. So we would say 2 over t minus 7. Again, multiply through. You get t minus 7 is equal to 8, and so then t is equal to 15. So then when you sum those two together, you get 27. Which is the same answer. Much simpler on the algebra, right? This is a lot simpler on the algebra. This kind of sucked, honestly. Like, I don't know. I read a bunch of, like, square roots and squares and, like, you know. And again, the number one thing on these competition math questions is being able to do things quickly. So finding elegant solutions that don't require writing a lot will help you out immensely in, like, scoring well. So just look at the difference in the amount of writing we had to do here versus the writing we had to do here. Not very much at all, right? And even so, like, a lot of this writing was superfluous. We just did it to, like, explain steps. So I think this is cool. This is a cool example of how using geometry can really, like, level up your ability to solve these types of questions without having to deal with a lot of math. Exactly, Psycode. Yeah, that question from yesterday where symmetry made it incredibly trivial. Yeah, the thing that was going 0 degrees and 45 degrees. They gave us a hint, right? Because they said sine of pi over 8. And we were like, when the fuck were we using sine of pi over 8? What pi over 8? And then you realize, oh, if I just split it down the middle, you get pi over 8, pi over 8. Yeah, that was a super cool one. Yeah. So cool. I think that's fun. I hope that's, like, a little informative to you guys, right? You know, this is why geometry. Learn geometry. One of my best math teachers I ever had in my life was my geometry teacher. I think he's probably one of the sole people responsible for me going into, you know, math-related things. Math and physics. Because my algebra teacher before that, like, fucking blew. Like, she sucked. Like, I really hated my my algebra teacher before geometry. My geometry teacher was, like, the best. He was a boss. He unfortunately died of cancer, like, 3 years later. No. But, yes, having a great math teacher can make a huge difference. So I also say this to people. If you have, like, shitty math teachers and you feel like that's deterring you from doing math, stick with it. Don't worry. Because you'll probably eventually hit a good teacher. And then once you get to the good teacher, that's when it really starts to hit you that math is fun. Math is cool. You can do a lot of cool shit with it. That's what my geometry teacher kind of showed me. And, like, that's why I appreciate geometry. Yeah, exactly. My Calc 2 teacher was rough, ended up failing the class the first time, but it happens. Exactly, Psycode. Totally. And it's okay to fail. Like, I know I always talk about my first roommate in college who failed calculus 3 different times. He failed the same class 3 times. It wasn't until the 4th time he finally passed it. And now he makes like so much more money than me. Shout out Matt Ridge. Good job, Matt. But it's okay to fail. What's not okay is to quit. You should always keep trying. Yeah, Psycho says the same. Yeah, I know people that did 2 or 3 times and they're incredibly well off today. Right. Just because, even it's a big character development thing. We talk about like aura farming and whatnot, but it's big character development if you don't get deterred by a challenge and you eventually punch through and do it. Because life is that. Life is a bunch of things that fucking suck. And you want to quit, but if you don't quit, there's some awesome rewards on the other side. Okay. Cool. So that was a good Kaylee question. Let's go find another one. I like that. And again, learn from solutions. People ask me, like, how do you get good at competition math? You get good at competition math by doing competition math. Because now that I've seen that question and I've seen that solution, if I ever see something similar to it, if I ever see points along a line, I know right away, let's just jump to drawing triangles. That's not something that's really taught. They don't teach you that in Algebra 2. They don't teach you that in geometry. You have to do it, and then you have to see the solution, and then that builds in your mind like a database of like, okay, when I have these types of problems, this is a cool trick. This is like a weapon in my arsenal that I can use. Okay. Oh man, I always suck at these, and that's why I'm gonna do it. Number theory stuff, which I think is kind of real analysis. This is what we call real analysis. Where's Zach? Zach's my real analysis guy. All right. There we go. We zoomed way out. Sorry, let's delete this. There we go. Okay. A Catendi number is a 4-digit positive integer where the first 2 digits and the last 2 digits, in order, form 2 integers that are increasing consecutive multiples of some positive integer. Okay, there are a lot of words here. This is already like... No. Okay. Form 2 integers that are increasing consecutive multiples of some positive integer. For instance, okay, I think I get it. I like the example here. 2025 is a Catendi number because you have 20 and then 25, which are consecutive multiples of 5. Right? So you have 4 times 5, which is equal to 20, and then you have 5 times 5, which is equal to 25. Right? So this is the consecutive part of it. Good. And Jeff is already kind of on the right path here. Jeff says, let's start assigning variables and start speaking that language. I 100% agree with that. That's a great idea. Okay. Yeah, so if we were, for instance, to how is 2346 a Catendi number? Oh, it is. Because 23 times 1 times 23 and 2 times 23. Right? This gets you this gets you 46. So 2346 is also a Catendi number. Yeah, very cool, right? Right, and then 2324 are Catendi numbers because, yeah, it's 23 times 1 and then 23 times 2. Or, sorry. It's 1 times 23 and then it's 1 times 24. Yeah. Sorry, what I meant to say was this. Okay. 23 times 1 and 24 times 1 is also a Catendi number because this is 23, 24. Yeah. Do you see how this goes up by 1? Good. Okay. How many Catendi numbers are there that are greater than 2400 and less than 2600? Wow. Okay. Well, I know right off the bat that 2400 is not a Catendi number, right? Because 24 does not multiple up to... And wait, and this says of some positive integer, so 0 doesn't count. So, for instance, you're not allowed to say 0 times 24 and then 1 times 24. Yeah, okay. 2432 Yeah. Right, 3 times 8, 4 times 8. That's a good one. Yeah, Alistair, that's a really good one. You could also do 24, 25. Right? 24, 25 is okay. Because this is 20, this is 1 times 20, this is 1 times 24 and then 1 times 25. So, yeah, all right. Let's maybe label things, because again, the way you do not want to do this question.
No.
You don't want to start writing out all the combinations, because that's a lot, right? Between 2400 and 2600, you have 200 different numbers, and you don't want to have to go through and like check all of them. So I like, yeah, Jeff's onto something here. 24xx starts with how many times can you write 24 as a multiple of two numbers? Okay, because then the other one works. Is that what we're saying? Let's assign variables to things. I kind of liked, Jeff, what you were saying there first. Like, let's call this like n, and then let's call this k. Right? So we need n plus sorry. You have n times k, and then n plus 1 times k. I see. Yeah, and then these would be contending numbers. But, oh, actually, very cool here. Okay. They actually made our life kind of easy here, right? Because the key thing you have to visualize here is that when you're doing these contending numbers, you're just breaking it up into 2 blocks, right? You have the first 2 digits and the second 2 digits. Okay? And the only possibilities for the first 2 digits is, first of all, 24. And then 25. Okay? Because I can't have it be 26. Because anything consecutive after 26 would be more than 2600. So, yeah. So let's think about, for instance, you can have 24, and then I think Jeff wrote this like XX. And then you can have 25XX. And you want to know how many ways can you write 24 as multiples of 2 numbers? Because then you're going to write the next one as the n plus 1 multiple of that. So yeah, let's think about this, right? So this could be 1 and 12, 1 and 24, 2 and 12, 3 and 8, 4 and 6, and then yes, and then it repeats back. But I think we want to maybe keep the repeating back. Yeah, I think we want the other ones though, Jeff, don't we? 8, 3, 12, 2. We do. Yeah. 24 and 1. Because here's what we're going to do, right? So 1 times 24 would be this first one, right? The next one that would be another integer multiple greater would be this plus 1. So that would be 2 and 24, which would equal to 48. Right? I think I'm gonna get to here, and I'm gonna do that. Both ways work, right? You can either add 1 to these, or you can add 1 to these. It's the same. Yeah, okay. I think because I was doing this, I was doing the first one, adding by 1. Okay, so that is a contending number, 2448. Let's check the next one. So instead of 2 times 12, you'd have 3 times 12. That equals 36, and that's why 2436 is valid. This would be 4 times 8, 32. Good. 5 times 6, 30. Are we noticing a pattern here? Oh, you notice everything's dropping by 4? So I'd venture to say the next one's 26, which I don't think it is, though. Sorry. This dropped by 12. This dropped by 4. This dropped by 2. Exactly. Yeah, sorry, I had that wrong. So then, this becomes 7 times 4, which is 28. This becomes 9 times 3, which is equal to 27. Very cool. Okay, so there isn't really a pattern. I was hoping there might be like some pattern here that we noticed, but you know, we don't see it yet. Okay, that's fine. And then this is 13 times 2, which is equal to 26. And this is 25 times 1, which is 25. Nice. Right, 28, 27, 26, 25, and 24. That's really cool. I don't think I would have noticed these other ones. I definitely got the 24, 25, but I don't think I would have gotten the 24, 26. That's really cool, actually. So good. Yeah, so from this, we got 1, 2, 3, 4, 5, 6, 7, 8. We got 8 total. So let's check 25, right? There aren't very many multiples of 25. There's just 1 and 25 and literally 5 and 5, right? So the options for that would then be 2 times 25, which is 50, and then 6 times 5, which is 30. And note, like, 5 doesn't really work. Good, exactly. Okay, so then there's 2 from here. So then the total number I think we see is 10. So we could say that, let's put these all together. So we're going to say, so 10 possible. What about 25 and 1? Ooh, I did fuck that up. You're right, Jeff. Yeah, so I saw this and I just stopped. But yeah, we should do this. 25 and 1. Oh, I would have got that wrong. Right. Yep. You guys are right. So this is 26 times 1. So 25, 26. Cool. All right, so that gives us 3. And so then the total should be 11 total. Okay, let's see if that's correct. Let's go check our solutions for the Kaylee. Kaylee says answer is 11. Cool. All right, and let's see like how they did it. That's actually I'm really proud of us for getting that. I usually hate number theory type questions. I'm not a big fan of them. I like pretty pictures and shit, but like just dealing with raw numbers. Ugh. But I think that was Jeff. You really helped me out there with saying like let's just start making factor trees, because then I could see that I just have to increase 1 on the factor tree. So let's see. Let's suppose 24ab. Okay, then the integers n and m equals 24 and m plus 1 is equal to ab. Thus, nm must be a divisor pair of 24. So nm is one of these pairs, right? Good. And then increasing it gets you that, and then you keep doing it, you get 8. Good. Okay, cool. Same way we did it. Nice. Good job, guys. Cool.
Well done.
Yeah, nice. Okay, do we dare go further? do we I see the next one, which is I think it's a combinatorics question. This one's gonna make me like seethe. I'm gonna get upset at this. We durst. Yeah, we have to. We're here, right? I set aside time in my calendar. I said we're gonna stream. We're gonna do it. Competition math. We're just waiting for the Romanian vampire to wake up at some point. Okay. Here we go. Amir or Amer. Wait, whose name is Amer? Is that a real name? Oh, it's an Arabic name. Oh, okay. It means long life, flourishing, or life itself. Wait, how do you pronounce it though? I didn't know AMR was a name. How do you pronounce? I want to see this. A in the father, a slight throat sound for the akhmeh. Wait, I want to see this.
We are looking at how to pronounce these names. We'll be looking at how to say more confusing Arabic names.
This is great.
Many people
I love
mispronounce
this.
as well.
This,
So
this
stay
voice
tuned
here is like so like
until the
smooth
end of the
jazz.
video to learn more. In Arabic, it is said as Amr. So just roll the
Amr.
R a little bit after the M. Amra. I guess in English you could say Amra or Amr.
Okay, Amr. We learned how to say this dude's name. Okay, Amr. Amr by Cindy and Derek. Divide n coins between them so that each receives a whole number of coins. Amr receives 1/3 of the total number of coins that By, Cindy, and Derek receive. By receives 1/5 the total number of coins that Amr, Cindy, and Derek receive. Cindy receives 1/7 the total number of coins that Amr, By, and Derek receive. Is this a Diaphantine? Yeah. So Jeff, you know, I need someone to explain Diaphantine to me. Diaphantine, I think, is just fancy math words for like problems where you can only have integers. So they're what are called like the Diaphantine equations, I think. And there are a specific set of equations where, so for instance, in this case we have coins, right? We assume we're not coin shaving, and the coins have to be a whole number of coins. You can't have half of a coin. You have to have integer numbers of them. And so Diaphantine deals with that. I still do not understand them, and I don't think I've really been taught them very well. But maybe we'll see how they come into play here. Well, let's see. All right, so let's maybe come up with some variables for everything. You know, so anytime you see something like this, let's start assigning variables to stuff, and then see what we can get out of it. Okay, so I'm gonna now call the number of coins that Amr has equal to A. So we have A, B, C, and D, and now I'm no longer gonna use their names anymore. They are just variables at this point. Okay, so A is equal to 1/3 of B plus C plus D. B, exactly, Jeff, right? Yeah. B is equal to 1/5 A plus C plus D. And then C is equal to 1/7 A plus B plus D. And then they say, N is less than 100. What is the largest value of N? Okay. Yeah, I guess is what makes this question interesting is I can find one case at which this works, but I'm trying to find the largest case. There are many cases for which this will work, but we're trying to find the biggest one such that N is less than 100. And then, right, okay. The total number of coins, which we're going to call N, right? That's equal to A plus B plus C plus D, right? Which, yeah, Jeff came up with a cool little thing here, which is because I know A is equal to 1/3 BCD, I know that BCD is equal to 3A. So let's kind of like squiggle, write something here, right? So we can say that B plus C plus D is equal to 3A. Okay, so N is equal to 4A. Good. Right. So now when I take this, right, BCD is equal to 3A, I can say that N is equal to A plus 3A, which is equal to 4A. Good. Okay. Yeah, and then there's some other cool things here as well. Yeah, I think good. I think Jeff is on the money here. Jeff, you're making up for yesterday so well.
That's dope.
Because this tells me that A plus C plus D is equal to 5B. And then this tells me that A plus B plus D is equal to 7C. Great. Okay. So from these totals, you're back to 1968 now. From these totals, right? I can now say that, okay, well, if A plus C plus D is equal to 5B, right? Then this, and this is 5B, and then 5B plus B is 6B. So that would also tell me that N is equal to 6B. And then from this one, we could also say N is equal to 8C. Right? I think that's what I want to say, because now I know that N has to be. So here's some cool stuff here, right? So N, our number here, has to be a multiple of 4, it has to be a multiple of 6, and it has to be a multiple of 8 in order for these to be whole integers, whole numbers, right? So, well, anything that's a multiple of 8 is automatically a multiple of 4. So this is extra information, right? Anything that 8 can go into, 4 can go into as well. So, oh, I see what you're saying. I think you just need the multiples of 6 and 8, right? So, for instance, 48 would work. And then N should also, 96 should also work, right? Yeah. So 96 is equal to 8 times 12, which is also, so that's a multiple of 8. It's also equal to 6 times 16. That's a multiple of 6. And then because of the 8 and 4s, right, it's also equal to 4 times 24. Great. Okay, but does that still work for D, though? We didn't say anything about D. Yeah, I'm tempted to think that N is 96, but I'm worried that D doesn't work as well. There is no rule. There is. Oh, I see what you're saying. Okay, so if N equals 96, right? Then that means, yeah, A equals 24. B is equal to 16. C is equal to 12, right? So D, in order for it to add up to 96, so that's 28. 20 plus 24 is 52. So 44. So D must equal 44. And I guess that works, right? Because, yeah, D being 44 is still a whole number, so that checks. And I think we baked in the properties of D when we did this. Now double check. Okay, we could double check. Okay. So B plus C plus D, right? That's 28 plus 44 is 72. And 24 is 1/3 of 72. A plus C plus D is 36 plus 44 is 80. And 16 is indeed 1/5 of 80. And then A plus B plus D is 84. And then, yes, 12 is 1/7 of 84. Okay, cool. So I think the largest possible value is 96. Nice. I think that's right. Let's go check. And it is. The answer is 96. Yeah, fucking Derek, dude. Derek's a greedy bastard. Nice. Excellent, cool. That's a cool question. That one was actually pretty easy. I thought that one was gonna mess us up. No. I was like, dude, I'm about to get wrecked. But again, just writing out all of the combinations, right, in terms of the variables, and then doing them will really help. So this was great. Cool. Okay, let's see. Dare we get even crazier? We durst. Jeff will say. We durst. Keep in mind though, this is 10th grade. I think if we were doing like the 11th or 12th, I'd be really melting. This is still kind of a challenge. It's still challenging me. Okay. This is what I say is equivalent to going to the gym, but for math. Right? You're lifting heavy things. You're doing hard math problems. And what that does for you is that when you have to lift lighter things, or again, do easier math problems in like whatever your regular classes are, it's super, super, super lightweight. It's easy. So there are advantages to doing this, besides being cool and having like math aura. What's up, Matsuka? Okay, cool. All right, let's see this. A circle has area A. A regular octagon has area 1/2 A, and a regular dodecagon has area 1/2 A. The circle has radius 3,000. The distance from the center of the octagon to each of the vertices is X, and the distance from the center of the dodecagon to the is Y. What is the integer closest to X minus Y? Okay. Right. Nice thing here. They at least told you like a dodecagon is 12. I knew octagon was 8. I was actually curious about this. This is just like that one question. Yeah, Machka, do you see how that happens so much in math? This looks very much like blank, right? They all kind of like look the same. So the solution should look like that one question, right? Do we remember the solution to that one question though? All right. All right. So this is. Also, why did they make the radius 3,000? Such a big fucking number. Because yes, that's right. Alistair, I finished season 1 of Has Been Hotel today when I was on the treadmill. Great season, by the way. I like it so far. It's a good show. I'm excited for season 2. Yeah, just dividing the triangles is easy. All right, let's see. They say it's easy. Yeah, season 2 is released. Yeah, I just saw it. Okay, so the area of this one would be pi r squared, which is kind of ugly, right? Yeah. So A, let's just write it down here, sorry. A equals pi times 3,000 squared, which, I don't know, I tend to like to write things in scientific notation. So this is 3 times 10 to the 3rd squared, which when you square it, that becomes 9 times 10 to the 6th. So you can say 9 pi times 10 to the 6th. That's what I would say. Right? It's a little bit nicer. Okay, cool. All right. And then I think we want to come up for and since pi equals 3.
Oh shit, not good.
Oh no, Jeff, pi can't equal 3. We can't do that. Can't have pi equal to 3, dude. Oh, you guys are great. Okay. So you want to divide this into triangles? That is correct, Alistair. That is a correct statement. Yeah, if you divide it by 2. Okay, if this is X and then this is X. Oh, man. And then I need the area of this. The angles do get ugly, right? Why? Yeah, because this has a total of 360. But it's 360 degrees divided by 8. Pythagorean theorem? Where are you going to Pythagorean theorem this bitch? Wait, what? Where are you going to do that? Where are you going to do that? Are you going to do this? Well, we don't know what this is. Okay, so 360 is, so we have 2 pi over 8. So, okay, each angle is pi over 4 at least, right? Yeah, we're gold. We are gold, as I do say, right? Yeah, because then this is 2 pi over 12. is equal to pi over 6. Great. Okay, cool. Okay. So, I know what this angle is, right? This angle is pi over 4. So, if this is x and this is x, isn't this square root of 2x? Right, is this length? Draw the altitude, he says. Oh, okay, yeah, sure, I can do that too. You mean like do this? Yeah, okay, I got you. Yeah, alright, let's draw the altitude. Okay, because the area of this is equal to, well, first of all, it's going to be 8. 8 of them, right? Times 1/2 base is x. But I think you can do this one. Right? Isn't this still okay, though, Jeff? Because I still know this is 45 degrees. I know the hypotenuse is equal to x. Right? So then I can figure out what this is. Yeah. Yeah, it's a key thing. So, yeah, Jeff's right. I could have drawn this as the altitude, but then I would need to come up with an equation for this and also an equation for this. An altitude, when you're doing 1/2 base times height, the height, or the altitude of the triangle just needs to make a 90-degree angle with one of the sides. So I'm going to make a 90-degree angle with this side. And then I already know that this is a 45, 90, right? So, whatever, right? This is, if you don't even need to use trig here. You could just use the Pythagorean theorem, right? Because let's say that this distance is a and this distance is a, right? I know that a squared plus a squared has to equal x squared. So a squared is equal to x squared over 2. So a is equal to x 1 over root 2. Or like that, I guess. And now we're good. Yeah. Or you could say x root 2 over 2. So 1/2 base, and then the height is going to be x root 2 over 2. I'm not sure. Wait, how does the root 2 go away, though, Jeff? I don't think the root 2 goes away. Am I going to have to take a year away from you? Yeah, okay. Right, yeah, right. So area 8. Oh, you said times. Okay, all right. Okay, 1/2 base times the height. You said about the A. Okay, good. Got you. Thank you. All right, cool. So this is 8 over 4, which is 2, and then x times x is x squared. So you get 2x squared square root of 2. I think. Okay. We haven't even gotten to the integer part, but we will get there. Okay. That's also true. This is, yeah, special episode. Naroski was supposed to be here and do some math stuff with us. I think he might be sleeping though, or he might have like not woken up yet. He is a Romanian vampire. But yeah, we have been doing primarily math competition questions. So we've been doing the Kaylee questions during today's stream. So we've managed ourselves. Yeah, Eric's a great guy. Let's say hi to Eric. Yeah, shout out Eric. We've managed to do, we've done 3 of these actually, right? We did 21, we did 22, we did 23, and now we're on 24. But yeah, we'll see. I'll follow up with Narowski because he had a lot planned for this stream. He like sent me a bunch of stuff. I was like, oh, I'm hyped. But then I don't know what happened to him. You think if you hear when the stakes are so high? Oh my god, Jeff.
Surprise, motherfucker.
Jeff. Okay, alright. Let's do this one. Here we go. Alright. So this is Y. Let's draw another altitude. This one you do need trig, I'm pretty sure. Right? Because we know each one of these angles is pi over 6. Right? So this is 30 degrees. We know this is Y. So, is this just Y over 2? Right? Because the sine of 30 degrees is equal to Y is equal to opposite over Y. Yes, good. And sine of 30 is 1/2. Right. So cool. That's just Y over 2. This is the 12-sided. This is the dodecahedron. Okay, so this is Y over 2. So then the area here is going to equal 12. And then 1/2. The base was Y. And then the height is Y over 2. Okay, cool. So, that's 12 over 4, which is 3. So this is equal to 3y squared. Great. Which makes sense, because 3 equals pi. Okay. Oh my god, Jeff. Okay. What is the integer closest to x minus y? Alright, alright. So, we know that 2x squared square root of 2 is equal to 1/2 times a, right? So 1/2 times this. And then 3y squared is also equal to 1/2 times this. And then, yeah, also that they're equal to each other. Today on Actual Education, I learned circle has 12 sides. Yeah. Difference of squares, he says. Oh, is that true? Oh, okay. Oh, because we want x minus y. Oh, very cool. Okay. Yes. Okay. Yes. So, yeah, and apparently the area of this is equal to the area of this because they both have an area of 1/2 a. So, okay. So 2x squared square root of 2. And sorry, we want x minus y. Okay, minus. You might be able to solve directly. But that pi's messing things up, though, right? Also the square roots. I like your idea here, right? Which is that x squared minus y squared, right, is equal to x minus y, x plus y. And then I think how is this gonna help us though, Jeff? Oh, yeah, wait. I think we can just do it straight from here. No? So, 2 square root of 2 x squared minus 3y squared. Isn't that equal to 0, though? Because they're equal to each other, right? This has to equal 0. It is, right? Okay. And then, so this is the same thing. You can get x squared in terms of y squared. From this, you could. I wanted to see if there was a clever way to... Yeah, the issue is that you're not going to get x minus y here, right? Because you have these factors out in front, which are going to mess with you. Get out! Oh, okay. Right? Yeah. This is smart. This is clever. I mean, I like it. I like giving you some E for effort here. It was cool. Okay, sure. Okay, so x squared is equal to... Yeah, exactly. X squared is equal to 1 over 4 root 2 times... Right? And then that y squared is equal to 1 over 6. Right? Yeah. And then we want x minus y. Okay. So do I want to take another square root though? This is kind of ugly.
Disqualified.
I don't want to take a square root of a square root. Right? Like the square root of pi?
Surprise, motherfucker.
Oh, there's got to be a nicer way to do this one. Because I want to say, I don't think you're allowed a calculator on this exam. Yeah, let's check. Calculating... Oh, calculators are provided. Oh, you can use... Sorry. You can use calculators, provided they do not have internet access. Okay. A computer algebra system. And okay. Oh, okay. So then we're money. All right. We can just do this manually. It's kind of silly though, right? I thought we'll check. The solutions after this might have something that's more elegant. This is straight math, right? Which makes me suspicious. Because usually you don't want to be just doing straight math. You want to do curvy math. Alright, so where's the calculator? Okay. Okay, so let's just get this number. 9 pi times 10 to the 6. It did take some work to get here. That's true. Yeah, let's not knock it. Let's not knock it. We did do something. I'm going to store that as x. So I'm going to say 1 over 4 root 2. Oh, I hate the math. What is it called? Math print? Math classic or whatever. Okay. That times x. And then we're going to square root that. So that gets us 2235.67. 67.
You done messed up, Aaron!
Wow, thanks for the sub, Pen. Our baby is 2 years old. I haven't touched my resub. I need to resub to you, Pen. Wow. Have we known each other for 2 years, Pen? Has it been that long? Friendship seems like eternity. I appreciate it, Pen. Alright, 1/6 times x. Square root that, dirty girl. We get 2170.8. I appreciate you too, bro. Hug, yeah. I appreciate you, Pen. I appreciate you, Pen. I was actually looking for you yesterday. Did you not do your Ocarina of Time thing? It's okay if you didn't. Narosky was supposed to be here doing pretty math with us, but I think he fell asleep. So around 65? Yeah. All right, so 65. That's the closest integer. Is that correct? What's up, Gladiator? Let's go see. So that was question 24. Answer is 65. You end up getting sick. Yeah, dude, there is definitely something going around, and I feel it in my throat already. Like, I already know, like, something's happening. So, I hope you feel better, Pen. Decided to sleep to try to get ready for D-Day. Oh, is that when your college starts, Pen? Is that the first day of the quarter? You know the first week of college doesn't count, right? Everyone's just, like, doing syllabus stuff anyways, right? Or, like, switching their classes. Oh, D-Day is MLK Day. Yes, yeah. Oh, we have a 3-day weekend? Ooh, interesting. Penn says, that's when I meet with the vice president to discuss where we think science is going over to next 5 years. Yeah. So apparently, once I saw my friend post this on his LinkedIn. Apparently science is safe. Look up. It's my friend Schaffner. This is like my physics older brother, I guess. There we go. Here we go. So apparently in the U.S. it's okay. So the U.S. Senate passes a bill to boost federal science. Dude, what's with all? Dude, I do not want a double salad. After White House sought major cuts. So apparently the Senate has approved significant funding for NASA, NSF, and NOAA, and it's veto-proof. So great. At least Congress is fucking doing something. Critics argued NSF funding lacks oversight and a clear public return. The White House had sought to cut the budget by 57%, yet nothing says great things like, let's just slash the science budget. Oh, I see. Yeah. Mostly, yeah. The military industrial complex always has money. I would say that if you want to always worry about job security, if you never want to worry about job security, work for the Department of Defense in some regards. You may be selling your soul a little bit, but that thing will never run out. Canada has a defense department. It's 2 moose and a super soaker. Oh man. I don't know. I get upset at this, right? Critics say NSF lacks any clear public return. Science doesn't have clear public returns. Like, none of it's clear. Do you think if I started my PhD, I knew what the clear public return would be on it? Like, what?
Surprise, motherfucker.
What? It's the whole point of science. You don't know what the fuck's gonna happen. Math doesn't have any returns whatsoever. I mean, a lot of the AI stuff is math, right? All the linear algebra and stuff. So, I mean, there definitely is some returns from math. And if you want to go to the real dark side and become like a stock market quant, then math has amazing returns. But I'll never forget my he was my undergraduate advisor. I did an undergraduate thesis when I was at UT. Great guy. His name was Roger Bankston. Also passed away. All of my great mentors have died, unfortunately. No. But I remember I was in his office once. It was probably like sophomore year, junior year, and I wanted to go into plasma physics because I just thought it was cool. I had done like a little summer research thing that he got me into at Princeton, and like I just loved it. I was like, plasma's great. And I remember he said, Giovanni, I gotta tell you, there's gonna be some decisions that you need to make when you go into science. You know, like do you want to discover beautiful things, or do you want to build bombs? And so, and that is when we talk about defense funding. If you're going into science and you want to make sure you have a job and you want to collect paychecks, you might have to develop some bombs. That's, at least in physics, that's where it goes. Physics does split. between studying just kind of like beautiful whatever things to, okay, even within like plasma physics within fusion, right? Fusion by definition is releasing large amounts of energy from nuclear reactions. So you can either do that in a calm, peaceful way to provide unlimited energy for the Earth, or you can have it explode uncontrollably in like violently destructive forms, and you have hydrogen bombs. So there's always like two sides to the coin here, I guess. So yeah, even within plasma physics, I know people that went to the quote-unquote dark side to go work for DARPA or Department of Defense or something, and they're basically doing nuclear bombs. What's up, Famished? Daddy Pen and Uncle Gold? I have been called Unc a couple times in the last week. Yeah, math. Yeah, you're right, Gladiator. Math makes a lot of money in banking and stuff. Yeah. But this is cool. So, anyways, best of luck, Pen. I hope you get all the funding you need for science and stuff. Science is important, and I don't think science needs to have clear public returns in order to be important. Never thought that. Yeah. If I wanted clear public returns, I would have been like, I don't know, an engineer maybe. Yeah. Okay, doth we try the last one though? These have actually not been too bad. I think next time we might step it up to the 11th grade one. Science is free. Science is most definitely not free. No. Have you seen how much science costs? Science is expensive. Knowledge is forever. Correct. That is correct. I'll give you that, Famished. But science is very much not free. It should be free, but it's not. Okay, Rita is coloring a picture of a flower. She already has colored the center. She's colored the center and the stem of the flower as shown. Next, she will color each of the 6 petals with exactly one of 2 colors. Red, orange, yellow, and blue. No 2 neighboring petals can be the same color, and not all 4 colors need to be used. There are n different looking ways in which Rita can color the petals. What are the rightmost 2 digits of n? Oh, this got difficult all of a sudden, dude. Oh, man. Okay. Alright, so there's 4 colors. A, B, C, D, right? I'm going to label them. I'm going to just say, like, what? Red equals A. So here. Instead of, like, all these fun colors, I'm just going to say colors. How many ways do you use 2? How many ways do you use 3? Yeah. Well, let's see the minimum number you would have to use, Pen, right? Yeah? You can't use 2 colors. Because no 2 colors can be the same. So if you did, like, for instance, A, B, A, B, A, B... Or actually, maybe you could. Oh, you can. Okay, you can use 2. You can't use 1. No. Can't use 1 color. Okay. Four choose 2 ways to use 2 colors. I think times 2 as well, though, right? Because... Oh, wait, okay. Wait, because I was thinking A, B, A, B, A, B is different than B, A, B, A, B, A, right? Those are 2 different things. But... if I do 4 choose 2 is I think I want 4p2. Right? I don't think you want just combinatorics. I can get behind that. Nice. Nice. Okay, 4p2. Okay, so for 2 colors, you have 4p2, which I actually don't know the formula for permutation 2. this technically is a calculator test, so you could do this, I think. I think you could go to, I think it's within, where's the probability space in here? Ooh, math? Yeah, I think you can do this. I think it's NPR, right? I think you can do 4P2. Yeah, it's 12. How did you get the 12, by the way, Jeff? How does that work? What's the math for a permutation 2? My first tea in 5 months. Were you trying to cut back on like caffeine or something? Ah, okay. Wait. So APB is equal to A times A minus 1 all the way to A minus B. Is that what we say? Yeah. I used to drink a lot of coffee. I think I've been kind of chilling on it, though. Okay, so I think this is 4 times 4 minus 1. Oh, and then you can't do 4 minus 2, right? It's ACB times B factorial or some shit. It's basically choose a formula without the denominator. Okay. We have our calculator, so let's just do it. That's fine. Okay. Okay, what happens if you have 3 colors, though? Because now I think there are going to be some restrictions, right? Yeah, 3 colors is trickier. Let's just draw, right? Let's say like A, B, C, A, B, C. I guess it's nice that there are 6, right? Ah, 4P2 is 4 factorial over 2 factorial. Oh, that's what it is. Okay, cool.
My man. Yeah.
Okay. I see. So it's A factorial over B factorial. Thank you. I know for A choose B, it's A factorial over A minus B factorial times B factorial. I think this is right? Okay. Nice, okay.
Good job.
Love it, pen. Okay, so this is for 3 colors. Now... so that works, right? But yes, also ABAC works. Yeah, that's the annoying thing, right? Because also ABAC works. Shit. I just keep reading all cops are bastards or something.
Surprise, motherfucker.
Okay, fuck. This is why this is the last question. They do this to us.
You done messed up, AA.
We were feeling so good on 21 through 24, and then 25 just comes and hits us like
Oh shit, not good.
a bag of bricks. Because we haven't even talked about like D now, right? Okay, fix the first 2. Then you have 2 choices for pedal 3. And then 2 choices for pedal 4. Okay, let's try that. No, I like that. I like that. That's a good idea, guys. So you're saying, okay, if this is A and this is B. Or actually, let's just say let's just fix the first one at A. Right? Now you have 3 choices here, right? Because this could be C, this could be B, C, or D, yeah? Then when you get here, you have 3 choices, right? Because it could be A, well, it could be, I mean, it's whatever this one wasn't plus A, right? Oh, I think I see. 3 choices. 3 choices. And then here, I want to say, I think you have less to deal with. Wait, and this actually will encompass all of them. Right? I think 2 choices, yeah? Because you can't be this one and you can't be this one. But what if these 2 are the same? Then technically you have 3 choices. Oh, this is the 4-color situation. Oh. But yeah, technically you cover the 3. I mean, technically I think I cover the 2 as well. Right? Yeah, I think it covers the 2 as well. This last one is what's messing with me, though. I don't know. I think... You think it's only 2, though, Pen, on the last one? Because what if it was, A, B, C, B, A? Do you see how, like, now I only have 1 choice. Sorry, now I have 3 choices here, right? This could be B, C, or D. If these are the same. So I don't think I have 3 choices here. Okay, well, let's just subtract the cases where it's the same, right? Okay. So let's say it was... What's up, Monkey Man? I'm finally on my break. All my exams are over. Congrats, dude. Okay, I think it's 4 times 3 times 3 times 3 times 3 times 2 times... I think it's times 2, but then it's gonna be adding some. Okay. I want to say it adds... Yeah, this is a competition question for sure. Testing. Is this internet on? It is.
Oh, yeah.
What's up, Eric? Greetings, Zach.
Oh, yeah.
What's up, Monkey Man? What do you want to ask me? What if you fix that pedal as A? I think you can start off with 4 to the 6 and subtract off ones with 2 in the same row. Inclusion-exclusion principle. Oh, I see what you're saying. Are you... Which pedal are we fixing as A, by the way? Sorry. Are we fixing this one as A? Because then there's 4 or let's just fix it as A. The one and the other one you're worried about? I am worried about it, dude. Okay, let's pretend that this is just A, right? Okay. Let's just pretend it's just A. Let's say just for A is the first one. Because I think I know what I want to do. Wow, thanks, A-Kip. Thanks for the sub. If this is A, then you have 3 times 3 times 3, And then this is where things are going to come in, they're going to be tricky, right? Okay. So, you do have 3 choices here, okay? But then, based on what this is, determines what choices you have here. So, if this is, B, C, or D, right? So, let's say, B, well, fuck. Ugh! But then it depends on this. Oh man, this is rattling my brain. Okay, fix the first 2. And then draw the tree diagram. Okay, you want to call this like A and B? Or, yeah, here, let's call this the first one, A and B. Sorry, let me move this. Okay, so A, B, and then you have 3 choices, right? CDA, right? So A, B, and then times 3, times 3, times 3, right? 3, 3, 3. And then here you have times 3 choices, right? Well, but then it depends on the one before. I think it's times 2. Oh, make a branching tree. All right, one sec. Let me read someone. Sorry, Big Monkey Man had a question here. Said, I'm looking to transfer to university. For that, I need a recommendation letter. I feel like a dick asking professors for a rec letter. I don't know why. It just feels bad seeing, as I kind of see it as like asking for a letter so I can leave. I don't know. Maybe I'm overthinking it. I'm number 1 in my program and have brilliant relationships with them, so I'd say they'd give me a good letter. I'm just thinking if I don't get accepted, I will have them again, and I don't know. I will feel like they realistically... Yeah, they don't care. No. I mean, it's okay. It's natural, Big Monkey Man, for you to be, like, overthinking this. These professors have their own lives going on. Their own, like, normal things going on. Like, whether you leave to go to a better university, doesn't really matter to them. Yeah. If anything, like, they want you to... I assume you're trying to transfer to a better university. Is that what you're trying to do? If you're trying to transfer to a better university, they will 100% help you. I don't know any professor that, like, wants to keep the student at their place. I guess, yeah. Well, it can work both ways, Zach, right? Yeah. So keeping you there can make them look good if you do good work. But also them sending you to a prestigious place can make them look good. Like, for instance, when I tutor kids, or I help them with college apps, or I write letters of rec, I love for them to get into great schools, because then that helps my, like, resume. Also, like, you know, I was thinking about this the other day. I don't really care how much I get paid for doing things, but I do care at like how meaningful the work I am, like how, if the work I'm doing is being impactful, right? If someone gave me a ton of money, but were like, nothing you do is gonna matter, then I don't think I would take it. I've had this with, like, and this is a big reason why I have some students that I tutor for ridiculous amounts of money. It's a lot of money, but I get really upset when they cancel on me, or they start doing badly in their classes, or they just start giving up, like they want to quit. On one hand, you should be like, oh, you should just be happy. Like, you made tons of money. Like, who gives a shit? Like, you know, they're paying you the same. And some kids do say that. They say, I'll pay you even though I'm canceling. And I'm like, no. I mean, the money's nice, yes, but what I care more about is that this effort I'm putting into to making you a better student so that you can succeed, I need that to, like, come to fruition for me to feel like my time is being used adequately for society, I guess. So when students say they want to drop out, I get really upset because to me, I feel like it's a sunk cost because I invested a lot of time into getting you to this point and now you want to give up. I'm like, no. I don't care how much you paid me. I need to see it through. You need to pass. Because otherwise I feel like my time's been wasted. Like I could have been helping somebody else who would have passed. I guess it's kind of how I see it. Monkey Man says, my doesn't do spintronics or nanoelectrics. They don't have any classes related to that. That's the main reason. Cool. I think if you tell your professors, if you ask your professors saying like, hey, I want to go into this field and it's not being offered here, I think they'd be more than happy to write you a letter of rec. I think you'll be okay. Okay. We only got 4 minutes left because I told the students I am going to play games with them. We're going to play Rocket League in 4 minutes. So I don't know if I'm going to get this off of the branching stuff. Yeah. Okay, so number one thing, Big Monkey Man, because I've been writing letters of rec for the last couple weeks here, because I have a lot of students that ask me to write rec letters. Provide your professors with kind of a brag sheet or like a resume. Like, remind them why you're dope. I have some students asking me for rec letters, and it's been a while, and I don't really remember, and in order for me to write the best rec letter, you should remind me why you're good. And then it'll jog my memory, and I'll be like, oh, yeah, that person did do that. Okay, cool. So, help your professors out and be like, hey, here's my resume, here's what I'm applying for. Could you please do it? And they would, it helps them to write good rec letters, and it's you know, then you're not being a dick. Okay, let me see. What was the solution? Jeff says, screw the games.
Oh shit, not good.
No, we have to play. I said this year I was going to play more games with the students. They voted on it, dude. I gave them a... All right, let's see what the fuck this was. Throughout the solution, we will use diagrams like the one to represent the ways to color a petal. Okay. You are not a democracy. How long should I give them? I have some in semester 2, so I want to maximize the time I give them. Give them at least 3 weeks. I'd say at least 3 weeks to write a letter. Okay. Oh, interesting. Okay, so they break it into cases. They say red is used 3 times. Veroni diagrams? What the fuck are those? Okay. The rest of the petals can be colored in any way using the other 3 colors. Oh, I see. So, yeah, 3 times 3 times 3, 27. Great. Case 2, red is used 2 times. There are 3 possibilities at which two colors can be colored red. Okay, cool. You can do that. You can do that. You can do that. But wait, what about what if like this is red and this is red? Oh, this is a very... So, apparently the answer is 32, science code. Oh, 732, yes. So, the last 2 digits is 32. Okay, you are correct, science code, by the way. Okay. In classic math competition form, the last problem is 2 pages long. Solutions are 2 pages long. So, Penn Center got 32? Nice, okay. I did not get it, but that's okay. Math is all about hitting walls and learning things. I think I might take a look at it later, but yeah, it's a compute science. Yeah. I'm classically bad at these types of questions. Combinatorics and permutations like always fuck me up, and so it's something I definitely want to get better at. So, yeah, for a future time. Okay. Well, we got 30 seconds left, and I want to make sure that I'm there for the students to play. We're going to play Rocket League. So if you want to come by and play Rocket League with me and the students, I'm horrendously bad at this game, but I told them anyone who beats me gets double entries into a giveaway. So we're gonna play some Rocket League. Let me get the stream started up. Rocket League.
Get me up on this damn stage. You've been talking all that shit.
I have been talking all that shit. Okay. All right. Here, I'm gonna start our stream on actual gaming. Okay. Yeah, if I had more time, I would have gotten it.
Wait, don't switch stream yet. Let me get my stream streak.
Wait. Yeah, wait. You're good. One sec. I'm gonna go through the chat real quick. Zach says, I want to do poly counting chromatic polynomials for this, but I feel like I don't learn the theory. Yeah. I'm gonna raid myself. I'm gonna raid our sister channel. So we have another channel called Actual Gaming. All right. Cool. All right. Thank you everyone for coming to the Gilded Method stream. I apologize that Narosky, I'll talk to Narosky. Maybe he also got sick or something. It's totally cool. But thanks for, calling the audible with me. I hope you guys learned some stuff. I definitely learned some stuff. These math competition questions are great math gym things to do. So, I appreciate you guys learning alongside with me. Our next stream where we're going to do homework help, that will be on, Sunday. But I invite you, if you're looking for help with homework, go check out our streaming schedule here. And you can see that Zach will be on tomorrow morning. So big shout out to Zach. Make sure to go follow him and go check out his stream tomorrow morning if you want math and science help. And then we will be back on Sunday, starting at 5 p.m. Pacific, 6 p.m. Mountain, 7 p.m. Central, 8 p.m. Eastern. Yeah. So, yeah, no, it's okay, dude. Monkey Man, don't worry about it. I do dumb things all the time. Today I learned what call an audible means. Yeah, it's a football term, I guess. You've never understood call an audible? Yeah, it's an NFL term. All right, we're gonna go over in Discord to the Recess channel. So go follow us on Discord if you're there. Otherwise, if you want to stick around in the stream, we're gonna go raid ourselves. I think I'm probably fine myself. Where am I? I better be following myself. Yeah, there we are. All right, cool. All right, so we're gonna go over there to Actual Gaming. Check it out. We're gonna go play some Rocket League. Eat an edible means. All right. Enjoy the weekend. Have a wonderful rest of your Friday. We'll see you on Sunday. Peace.